Hello and welcome to the Weems and Plath 2102 Starfinder basic course on how to use. My name is Joe Lynch. I will be your presenter today. Let's start from the beginning. Well, that's a good place to start anyway. 2102 Starfinder is a mechanical device used to plan a celestial navigator's sites that he intends to take to determine a fix for his vessel. It's a continuation. You do it in the morning, you can do it in the afternoon, you can do it in the evening, whatever time you want, whenever you can get on deck. Now, why are we using a mechanical device at the time of electronics? Well, quite simply, electronics fail. We all know that salt water and electronics do not go very well. We know that electronics can fail, batteries can discharge, and a whole slew and plethora of problems can go wrong with electronics. Now, that's not to say that electronics are bad. Electronics are very good. GPS, course plotters, the whole 9 yards, if you will, are excellent tools to use. They can get you to within literally yards of where you really are. Unfortunately, you can't do that with a sextant or with celestial navigation, but you can get within a couple of miles and then it becomes seamanship, which is what they did when we had wooden ships and iron men and with age of sail. So this course was designed, or this presentation actually was designed for the person who has had a rudimentary basic education, if you will, training in celestial navigation. Something similar to what you would find, say, in a junior navigation course put on by the United States Power Squadron. It's a very good course and something it would behoove everybody to learn from. Part of this requires this course requires that you have some knowledge of celestial navigation. We're going to use terms such as LHA and GHA, and you need to understand that because we're not going to go into those basics, okay? So let's start off. To do this course, you need a nautical almanac, right? This one. Where are we? Okay, here we are, nautical almanac. I got to remember it. I got to go right to go left, okay? I am not a videographer. I am an instructor of navigation. And we also have the Weems and Plath Starfinder. Okay, it's right here. This is the basic template. Right here, this template that you're seeing has a N. Let me get that up right there. There's the N. The N stands for the Northern Hemisphere, and if we flip it over, you will see an S. Yes, you will see an S if I turn it around correctly. That says Southern Hemisphere. And these are the stars that typically a navigator would see, the Northern Hemisphere or the Southern Hemisphere, wherever his DR has placed him. On top of all this, we have a series of templates. This is a template here, and this template is set for what a navigator would normally see at 45 degrees north. He flips it over to the other side, and it will say 45 degrees south. This template works both north and south, depending on where you are. Okay, so since we're going to be in the northern hemisphere, we're going to use the northern template, and we're going to use the northern overlay. Okay, very simple device. You just find one, you find the other, and you got a little peg in the center. You plop it on. Now, that doesn't say that the Starfinder is only good for 45 degrees. On the contrary, it's good for anything from 5 degrees north or south, and then there's 15 degrees, and there's 25 degrees, and 35 degrees, and 45 degrees, and it goes all the way up to 85 degrees. Okay, so at that point, you're in the high altitudes, and navigation can get a little tricky up there. Okay, also on the 2102 Starfinder, we also have the ability to find planets. This is done with this template. Let me point out at the very beginning that the Starfinder are blue templates, overlays, if you will, and the planet finder for finding your planets is a red overlay. Okay, we're only going to talk about the star finder and finding stars today. Okay, very good. So let's get started. We know that we have a longitude and a latitude that we've maintained because we're good navigators. Okay, and we started off with that part. We keep our DR. Now we have to decide what time do we want to get up in the morning? What time do we want to do our sites? Okay, and what day we're going to do our sites. So if you can see up here on my board, I hope you can see this, I've established our DR location. And in this case, it's 41 degrees, 4.35 minutes north. That, by the way, happens to be Connecticut. Okay, 73 degrees, 7.50 degrees west. Further defines Connecticut, and it also defines where I happen to be right now. Okay, so that's what we're going to use for our DR location. Our date that we're going to take our sites is going to be January 6, 2015. Okay, and the time that we want to be on deck is approximately 0600 zone time, or what our local time is. Okay, what our watches say. Okay, now in order to get there and find out what we have available, we need to determine what is called the local hour angle. Now, you all learned about the local hour angle in your previous navigation studies. Local hour angle, or LHA. Okay, and what we're going to look for is we're going to look for the LHA of Aries, that magical, mystical point that ties all the star locations together and the planet locations. Okay, and LHA is determined by the GHA, or the Greenwich hour angle of Aries, plus or minus the longitude that you are in your DR. Okay, if you are east of Greenwich, your longitude would be added, and if you're west of Greenwich, your longitude would be subtracted. It's very simple math. Okay, so GHA of Aries is in our case would be plus or minus our longitude of 73 degrees. So we start off with, we have to find out what time we're going to be on deck. And we said 6 o'clock. Now you remember your zone times and your zone descriptions, I hope, from your previous classes in navigation. Zone time is our local time. What time is it right here where we are? And what time we want to be on deck in this case. In this case, it's 0600. Our zone description, or how many sections of 15 degrees are we away from Greenwich? And in this case, we're 5 hours away. Okay, that's, you can tell that by just looking up on any time clock and find out what time it is in Greenwich, England, or London, England, and you'll get a pretty good idea. And you'll notice that in my case, it's 5 hours. Okay, if we were out toward the Michigan, Wisconsin area, it'd be 6 hours. And we just keep on going as we go west. It adds more time. So our zone description is 5. Our zone time is 6 o'clock, 600 hours, giving us a UT, or universal time, or a Greenwich mean time of 1100. Okay, so now we need to find out where are we as far as Aries goes at 1100 on January 6th. We start that by opening up our almanac. In this case, it's page 12. Very simple. We're at the beginning of the year. Scan down to Wednesday, January 6th at 1100 hours, and our GHA of Aries is 270 degrees, 28.2 minutes. That's our GHA, our Greenwich hour angle for Aries at that point. So we have it right here. Greenwich hour angle is 270 degrees, 28.2 minutes for our hour angle. Okay? Yes, I haven't made a mistake there yet. So LHA Aries is equal to GHA plus or minus longitude. So LHA Aries, this little V sign is the symbol for Aries. It's 270 degrees, 28.2 minus 73 degrees, 7.50 minutes. That gives us at 1100 hours an LHA of Aries of 197 degrees. That's the secret. That's all the math that we have to worry about, okay? We go back to our starfinder. And as I said, we pick up our starfinder and we make sure that we're in the northern hemisphere, because that's where we are. We head that up, and we find a template that closely fits our latitude. Okay, and I said we're latitude 41 degrees. We have a 45-degree template overlay, if you will. Now on the overlay, there's a big old arrow. Okay, and this old arrow here is going to point to this as this ring of compass readings all the way around here. It starts at 0 and goes all the way to 360. Okay, can we all see that here? Right here, 0 to 360. And this is the LHA, the local hour angle. So we're going to look at and take this blue arrow and we're going to rotate that around until we find 197 degrees. Okay, where are we? Oh, we're going the wrong way, but we'll get there. 197 degrees. Of course, 195, 196, 197. Now, what does that do for us, 197? At 197 degrees, you see we have this overlay. On this overlay, we have these concentric circles that get smaller, and it has the numbers on the outside right here. Okay, what that is telling you is these numbers on the outside ring are your azimuth. It's your compass reading, if you will, of where you are and where you're going to be looking for a particular star. The numbers going up here, right by this line here. Okay, if I can get this closer to you. Okay, let's see if I can do this. Okay. Right here. Excuse me, I'm not very good at videography. Right here, this is our altitude line. So those lines, as we go around, represent altitude from sea level. So at 197 degrees, let's start looking. And we can look on this, and we can come up and we can find an object. And the first object that I see here is, let's try Arcturus. Arcturus is a good one. Arcturus is sitting at approximately 60 degrees in altitude, and Arcturus is sitting at somewhere around 150 degrees. Okay, I'm just doing it roughly. It's probably closer to 145, but we'll take 150 for the time being. Okay, what does that say to you? Well, we know from our almanac, and we know from our training that Arcturus is a first magnitude star. That means it's really bright. And that tells you that, and how this tells you that is that by looking at the symbols, a big wide circle with a dot in it tells you that that's a first magnitude star. And as they get smaller, they go from first magnitude to second magnitude to third magnitude. You usually want to stay in your first magnitude stars. So we're looking at here and we're saying Arcturus, because this planet says out here, says that Arcturus is at 145 degrees and it has a 60-degree elevation. So if I went on deck, knowing that, I can stand on my foredeck with my sextant in my hand, and when I get ready to take my sights at around 6 o'clock, we would have civil twilight, because that's we've already figured that out. At about 6 o'clock, I can come around to 145 degrees true, and I can look up approximately 60 degrees, and I will see a very bright star. That bright star, I can now shoot with my sextant, take a sight on it, bring it down like I should do a good sextant sight, and I can determine my location with that one, what would be an EP at that point in time, just an estimated position. But I can go through here in my planning before I even get on deck, and I know that I can do Arcturus, and I've already figured out, let's see, can we get there? Okay, where are we now? Can I get there? Okay, I hope everybody can see that. It's all fun. I've made a list of stars that we will be able to see on January 6th at 6 o'clock on deck if we were on this latitude and longitude. And we can see that Regulus is a star, and it's at 245 degrees azimuth, 40 degrees elevation. Arcturus, as we already said, was 145 degrees at 60 degrees elevation, altitude rather. Vega, which is at 65 degrees azimuth, and 30 degrees altitude. Deneb, 42 degrees and 15 degrees. And finally, Antares, which is at 135 and 8 degrees. Antares may not be a good site, okay? Only because Antares is going to be close to the horizon, but you can still probably bring it down. You might be able to get a good sight out of it after all. Now as you can see here, very simple. Little math, quick reference to your nautical almanac, and then applying the starfinder in the correct latitude and at the LHA, the proper LHA. And you can pick up the stars you want. You record those in your notebook, you come up on deck, you take your sights, and you're done. How's that? How can that be more simple? And you can also use it to check your GPS to see if you're okay in your plotter. Either way, it's a good tool. I hope you learned something, and I hope to see you all again. So take care and happy navigating. Bye.